Hi everyone. Today we're going to learn about the application of exponential and log functions. One of the applications of exponential functions are growth and decay. That happens when quantity or number or population of something increases or decreases by an exponential growth. In these kind of cases, the general form of the function of this growth or decay is similar to a equal to p e to the power of r times t. So a here is the amount at time t, p is the initial amount. I can also call the amount at time t as final amount. And e to the rt is rate of growth or decay, r is the exponential growth or decay constant, and t is time. So we're going to do some examples of these kind of applications. Let's first of all talk about half-life. Half-life of a radioactive substance is the time it takes for decreasing by half or fall to half of its original amount. For example, let's say I have 4 grams of a radioactive substance and it takes 5 days to reach to half of its original amount, like 2 grams. So I can say the half-life of this substance is 5 days, because it takes 5 days to reach to half of its original amount. So let's do one example of this kind of problem. A certain radioactive substance has a half-life of 248 years. How much of a 10-gram sample will remain after 150 years? So it's asking how much of a 10-gram sample. That means this is the initial amount. So this is the p-value. Remain after 150 years. So this is the value of t. And it's asking how much will remain. That's actually asking for the final amount. What is the value of a? So I'm going to use this formula, a equal to p e to the power of rt. So I'm looking for a. P is given as 10 and e to the power of rt. I know that the t is 150, but r is unknown. So I'm trying to solve for a, but here I have two unknown variables. One is r, the other one is a. So I'm not able to solve it. In order to solve for a, I need to find r first. So I'm going to find r using the first part of the problem, which says half-life is 248 years. So I'm going to use the same formula again, a equal to p e to the power of rt. But this time, because it says half-life, that means the amount or the time it takes for this substance to reach to half of it. So let's say it was 2 before, like the initial amount, let's say it was 2. Because the initial amount is not given, you can choose any number as your initial amount. But make sure your final amount is half of it. So it's 1. So it was 2 grams, now it's 1 gram. Once again, because the value of the initial and the final amount is not given and it's just talking about the half-life, so I can choose any number for p here. You can also choose, let's say, 500, and then the a value will be 250. Choose 800 and the a value will be 400. But 2 and 1 are easy than every other number. So a is equal to 2, e to the power of r, which is unknown, and t here is 248 years, because that's the half-life of this substance. So now I'm going to start solving for r. The first thing that I need to do here is to divide by 2. So 0.5 is equal to e to the power of 248 times r. Now I need to solve for r because this r is actually on the exponent of this exponential function. I need to set this free and get rid of exponential. So I'm going to change this to log form. Because the base is n, it will be natural log of 0.5 equal to 248 r. Now I divide both sides by 248 and r will be equal to natural log of 0.5 divided by 248. Now I'm going to use my calculator to find the value of this. So to find this value, I'm going to use natural log of 0.5 and divide it by 248, and it's equal to negative 0.0027. So negative 0.0027. That's the value of r. Now I'm going to use this r into this equation over here and solve for a. So a will be equal to 10 times e to the power of negative 0.0027 times 150. So 10 times e to the power of negative 0.0027 times 150, and it will be 6.66. 6.66. So this is the final amount after 150 years. So 6.66 grams is the final amount. In the next problem, it says the number of bacteria in a certain culture has an initial amount of 500. So this 500 is the initial amount. So this is P. If the number of bacteria triples every 3 hours, so if P is 500, it triples after 3 hours. That means the final amount will be 500 times 3, which is 1500, and the time is 3 hours. It's asking how long will it take to reach to a count of 2000. So this is my new final amount. It says how long does it take to reach to this point. So I need to use this exponential function. A is 2000, P is 500, e to the power of r, and t. It's asking for how long will it take, so I'm looking for t, but also I don't have the value of r, so I need to find r from the first part of the problem. Then I come back here and solve for t. So I'm going to use a equal to p e to the rt here again. 1500 equal to 500 e r times 3. So I divide both sides by 500. 3 will be e to the power of 3r. Then I change this to log form. Natural log of 3 will be 3r. Then divide by 3. So r will be natural log of 3 divided by 3. And natural log of 3 divided by 3 will be 0.366. Now I'm going to use that here. So 2000 is equal to 500 e to the power of 0.366 times t. Again, divide by 500. So 4 will be e to the power of 0.3660. Then change this to log form. Divide by 366. And from here, if you use your calculator, you will see that t is equal to 3.78 hours. Okay, so for this problem, we have the population of the city increases by 3% per year, so this is the rate. If the present population is 600,000, what will be the population in 12 years? For population, again we're going to use the same equation, exponential growth, but this time we just have different names. So yt is the population after time t, and y0 is the initial population. So there's actually nothing different except that the name of the variables are a little bit different here. So I'm going to use the same formula here. Yt is equal to y0 e to the power of rt. Y0 is my initial population, which is 600,000. Then e to the power of r is 3%, so I can write it as 0.03. And time is 12, so multiply this by 12. Now I'm going to use my calculator to find this value. So 600,000 times e to the power of 0.03 times 12, which will be 85997, 85997 point something. Actually we had 3 nines here, so 85997.6, which, because we are talking about the population, we cannot have decimal number. You can just write it as 85997 or round it as 86000. The next type of application of exponentials are banking applications. We know that if we put our money in a bank account, we will get some interest. Sometimes the interest is compounded continuously. So if it's compounded continuously, we can use this formula, the regular exponential growth function, to find the interest that we get on our money. But sometimes the interest is compounded after a specific interval. In this case, we're going to use this formula. A is the final amount, P is the initial amount, R is the rate, and T is the time. The only difference here is the value of N. N is the number of times that our money is compounded in 1 year. At the bottom of the page, I have written some keywords about the N. If your money is compounded yearly, N is 1. If it's semi-annually, N is 2. If it's quarterly, N is 4. Monthly, N is 12, because we have 12 months in a year. Weekly is 52. And if it's daily, it's 635. So based on the keyword that is given on your word problem, you can decide about the value of the N. So let's do one example here. Sam is investing $800 into an account that earns 3% annual rate. So this is my initial amount, and this is the rate, 0.03. If the interest is compounded monthly, how much would he have after 5 years? So this keyword of monthly gives me the information that I need to use this formula. And the value of N will be 12. A will be P 1 plus R over N to the power of NT. P is 800, 1 plus 0.03 over 12 to the power of 12 times t, which is 5. Now I'm going to use my calculator to find this value. So it's 800 times 1 plus alpha y2 and 1 to get the fraction. So it's 0.03 over 12. Then this should be raised to the power of 12 times 5. 12 times 5. And it will be 929.29. 929.29 dollars. So this is the amount that we will get if the money is compounded monthly after 5 years. What if the interest is compounded continuously? From this word we learned that we need to use the first formula over here. So I'm going to use this formula, A equal to P e to the power of RT. So 800 is e to the power of 0.03 times 5. So we have 800 times e to the power of 0.3 times 5. It will be 929.46. 929.46 dollars. So that means if you have compounded continuously, then you will have more money. Okay, let's do the next problem. Miss Scott has $3,500 invested in an account at 5% annual interest rate, compounded monthly. So this word monthly tells me that I need to use this formula. And it's monthly, that means n is 12 here. How long will it take for the account to reach to 5,000? So the value of A is 5,000 and P is 3,500. So 5,000 will be equal to 3,500 times 1 plus R is 0.05 over 12, 12 times T. So we're looking for the value of T. To solve for T, first of all, let's get this exponential part by itself. So I'm going to divide both sides by 3,500 and 5,000 divided by 3,500 will be equal to 1.428. And then I will find this part using my calculator. So it's 1 plus 0.5 divided by 12. It's 1.004. So this will be 1.004 to the power of 12t. Now I need to solve for t, so I'm going to change this to exponential form. Log form. So log of 1.428 base 1.004 is equal to 12t. If I divide by 12 both sides, then t will be equal to log of 1.428 base 1.004 divided by 12. Now I'm going to find this value using my calculator. Okay, so I need log base here. So I go to alpha window and number 5 gives me log base. The base is 1.004 and the argument is 1.428. So this value should be divided by 12 and is equal to 4.238. So I'm sorry, I forgot that. 74.238. 74.23. So it takes almost 74 years to reach to this amount. Actually, I made a mistake here. This base here was 1.004. I had added one more zero here, so I'm going to do it again for you. So alpha window 5, base is 1.004. And here we have 1.428. This should be divided by 12 and it's equal to 7.43. So it's actually 7.43 years. Okay, now let's do the last problem. Mary invested $2,000 in an account 7 years ago. So this is the initial amount. Time is 7. If the interest was compounded quarterly, so if it's quarterly, that means n is 4. And the money has doubled in that time. So that means whatever was my p value, now it's going to be doubled. So p was 2,000, now A or final amount will be 4,000. What was the interest rate rounded to one decimal? Okay, so I'm going to use this formula, A equal to P 1 plus R over N to the power of NT. So 4,000 is equal to 2,000, 1 plus R over 4, 4 times 7. The first thing that I can do here is to divide by 2,000. So the left side will be 2. The right side is 1 plus R over 4 to the power of 28. Now I need to solve for R, but this R is stuck here in parentheses with a power of 28. So I need to get rid of this power of 28. The best thing here is to take the 28th root of both sides. Now this way, this 28 will go away with this one. So I will have the 28th root of 2 is equal to 1 plus R over 4. Then I subtract 1 from both sides. So 28th root of 2 minus 1 will be R over 4. Then multiply both sides by 4. So R will be 4 times 28 root of 2 minus 1. So to find the exact value, I'm going to use my calculator. 4 times 28 root of 2. So I go to alpha window and choose number 6, 28 here, and then 2 here, minus 1, and that's equal to 0.01. So R is 0.01. Oh, I'm sorry, it's 0.1. It's just 0.1. Let me fix this for you. It's 0.1. So that's the rate of this interest actually. So this was today's lesson. I hope it was helpful for you. Have a great day.